Hello everyone, this is Bhavani, Assistant Professor in IT Department at SMIT. Now we are going to look into the subject AML, Artificial Intelligence and Machine Learning. Subject code will be CS3491. Okay. Moving on to Logistic Regression Introduction. It is a classifier used for binary classification. Okay. It is called regression, mainly used to predict categorical outcome. Okay, it uses sigmoid functions z equal to omega power 3 x plus p. Okay, there are three types of logistic regression: binary logistic regression, multinomial logistic regression, and ordinal logistic regression. Application where we use this logistic regression will be spam email detection, disease prediction, credit risk analysis, customer churn prediction, sentiment analysis. Advantages will be output quality, simple and efficient, works well for linearly separable data. Moving on to sigmoid function, it's also called as logistic function, which gives the output in S-shaped curve. Mathematical function that converts any real value number with between 0 and 1. Widely used in logistic regression and neural networks. Okay, mathematical formula will be theta of x equal to 1 by 1 plus e power minus z. Okay, why we need to use the sigmoid? Because it converts linear output into probability, suitable for binary classification, easy to compute derivative, works well with gradient descending. Application where we using the sigmoid function will be logistic regression, neural networks, binary classification problem, and probability modeling. Okay, moving on to probabilistic discriminative model. Directly models the conditional probability P of y by x. It predicts the probability of a class labeled y given the input feature of x. Instead of modeling how data is generated, it focuses only on separating classes. Focus on decision boundary, does not model data distribution. Logistic regression is example. Learns direct mapping, optimizes classification accuracy, requires labeled data effectively in many problems, and simple implementation. Moving on to Navy Bayes introduction is a generative classifier based on Bayes theorem. It's called Navy because it's assumed that all input features are conditionally independent and give the class label. Bayes theorem formula same P of C by X equal to P of X by C into P of C whole divided by P of X. There are three types of Navy Bayes: Gaussian Navy Bayes, which is used for continuous data; multinomial Navy Bayes, used for text classification; Bernoulli Navy Bayes, used for binary features. Moving on to probabilistic generative mode, models joint probability, learns data distribution, uses Bayes rule for prediction. Navy Bayes is example, handle missing data as well, provide probabilistic output based on strong assumption, computationally efficient, useful in classification tasks. Then maximum marginal classifier. Separate classes with maximum margin. Margin is distance between classes. Larger margin improves generalization based on optimization problem. Uses support vector. Sensitive to outliers. Works well with higher dimension. Foundation of SVM and powerful classification method. Moving on to support vector machine is a supervised learning model used for classification and regression, finds optimal hyperplane, maximize margin between classes, uses kernel functions, handles nonlinear data, robust against overfitting, effective in high dimension, widely used in practice. It is powerful supervised learning algorithm used for classification and regression. It finds the optimal hyperplane. It separates data points of different classes with maximum margin, high dimensional spaces, and it's widely used in pattern recognition tasks. Hard margin support vector machine used when data is perfectly linear separable. Moving on to kernel tricks, kernel maps data to higher dimension, handles nonlinear problem, avoids explicit transformation. Common kernels include polynomial, radial basic function is popular, improves model flexibility, computes inner products efficiently, important in SVM, enhances classification power. Moving on to hard margin SVM, used for linearly separable data, no misclassifications allowed, maximizes strict margin, sensitive to noise, works when data is clean, solve quadratic optimization, produces clear boundary, simpler formulation, basic for soft margin. Moving on to soft margin SV, which allows some misclassification, introduce lock variables, balances margin and error, controlled by regularization parameter, handles noise dataset, more practical approach, improves generalization, widely applied, and flexible classification models also used for soft margin SV. Moving on to decision tree introduction. It is a tree structured model used for classification and regression. Splits data based on features. Internal nodes represent test. Leaves represent outcomes. Easy to interpret. Handles categorical data. Nonlinear decision boundaries. Popular machine learning algorithm. Thank you.